Today we're looking at lesson 3.2, which is on rational numbers. This is for pre-algebra. We're going to write each rational number as a fraction. Later on in the lesson there's a chart, and I'll show you the difference between what makes a rational number what it is and what other kinds of numbers you will see. But this is called a rational number, so if we're writing it as a fraction, we need to make this mixed number into a fraction. So we need to multiply 4 times 3, our whole number, times our denominator, which is 12, and then we need to add the numerator to that, and this will be our new numerator, and then our denominator will stay the same as 3, so our fraction would be 14 over 3. Here, if we're writing the number 7 as a fraction, or any whole number as a fraction, all they mean is write it as the number over 1. So if you had any number at all, whether it was positive or negative, and it's a whole number, you would put it over 1 to make it a fraction. Here we need to write each decimal as a fraction or mixed number, and everything always needs to be in simplest form, especially with fractions. So for writing decimals as fractions, you need to look at the place value of the decimal point, and then you have, or not, the place values after the decimal point is what I meant. So here we have the 8 is in the tenths place, and the 4 is in the hundredths place. So to make this into a fraction, we start by putting the number over the hundredths place, or 100. And then we can simplify this even more. We can divide at least by 2. So if we divide by 2, that would give us 42 over 50. And we can divide again by 2 to get 21 over 25. And then I believe that's all we can do. So our simplest form is 21 over 25. And then for the next one, we're going to know that this is supposed to be a mixed number at the end, where 5 is the whole number, but we need to make sure we write 875 as a fraction. So we go from tens, hundreds, to thousands, so we're going to simplify 875 divided by 1,000. And again, we can simplify this by dividing by 5. And actually, you can divide by a little bit more than 5. Let's say 25. If we divide 875 by 25, we get 35. If we divide 1,000 by 25, we get 40. And we can actually continue to divide here by 5 to get 7 over 8. And then we're going to put the 7 over 8 with the 5 that was already there to make the end result a mixed number, 5 and 7/8. So if the number is in front of the, or to the left of the decimal point, that's going to be your whole number in the mixed number. And then the part to the right of the decimal point, or after the decimal point, is going to be where you get your fraction part. Here we have a word problem where it says rock music accounted for 0.35 or 35 hundredths of the total music sales in a recent year. We need to write that decimal as a fraction. So I just said 35 hundredths because the 5 is in the hundredths place. So we're going to put 35 over 100. And we can divide by 5 again. So we get 7 over, 7 over 20. And that would be as simplified as we can get. The next problem, we're taking a repeating decimal and we're writing this as a fraction. Now, the book has a kind of complicated process for this, but what I want you to know is that there's a shortcut method. And if there's anything that's repeating and you're trying to write it as a fraction, instead of it being over 100, since the 2 is in the hundredths place, we're going to put it, since it's repeating, over 99. And that is where we start. And we can see if we can simplify this a little bit more. which we can divide by 3. So we get 14 over 33. And that's as simplified as we can get it. But the shortcut to this particular problem, when you have a repeating decimal that you're trying to write as a fraction, don't put it over 100, or don't put it over the number itself as the place value. Like I said, this 2 is in the hundredths place, so that's normally what I would put 42 over 100 and simplify. But since it's repeating, instead we go to 42 over 99, so 1 less than the decimal place that it's actually in. And then we still can simplify, but that's the starting process for this. And then the next part has to do with the picture that I was talking about in the beginning. I'll show you what it is. Here we have a Venn diagram of examples of rational numbers, and then we get more specific as we get closer into the circle. Notice that we have rational numbers outside of the circles, and those are pretty much any number that you come across at this point. And then integers get more specific. They can be positive or negative, but they can't be decimals or fractions. So that's what it shows you there. Then you have whole numbers, which can't be positive and also can't be fractions. And then you have natural numbers. And the only difference really between whole numbers and natural numbers is natural numbers are counting numbers. So you don't count 0 usually when you're counting. So 0 would be included in whole numbers, but it wouldn't be included in natural numbers. But that is really the only difference between whole numbers and natural numbers. So we're going to look at these numbers and identify which set or sets that they belong to. They are after. So 0, we just talked about. 0 belongs to the whole number. And then how you can determine all of the sets, well, we can go backwards, and it's anything that's included with the whole number. So basically it's everything except for a natural number. So it's a whole number, it can be considered an integer, and it can be considered a rational number. Then you have 1 4/5. This, we talked about integers having to not be fractions, but they can be negative. So this is actually technically a fraction, so this is only a rational number. And then, I didn't talk about this, but on the chart we could include irrational as part of it. And irrational numbers are pretty specific. Basically, irrational numbers, an example would be pi. You've heard of pi before, not pi that you eat, pi as in 3.14. That's an irrational number because it's a decimal that never ends. So if it, and it's called a non-terminating decimal, okay, it doesn't repeat, it doesn't end. So if we look at this last number, this is a decimal that's not repeating, and it looks like it is never ending because it has these dots at the end of, to the right of that 2. That means that the numbers keep going. So the only option for this type of number is it's an irrational number. Okay, and basically irrational numbers are only numbers that are decimals that don't repeat or don't end. And that concludes lesson 3-2.